Hi, I'm Cullen. Welcome back to Networking Fundamentals. We're going to get started right now with Module 5 and continue our journey through understanding wired and wireless networks. Let's go ahead and get started. Let's take a look at the agenda on screen here. Like I said, we're going to cover Objective 1.4, Understand Wireless Networking. And so that means that we've got to understand wireless devices and wireless standards. All right, so let's talk about wireless networks. For a wireless network to work, all devices have to be connected through a wireless network adapter. And so it's a little bit different from the wired one that you guys saw a picture of earlier in one of our modules. I think it might have been Module 2. I can't recall. Don't hold it against me. And so those devices, they connect through radio signals to a wireless access point. That wireless access point, of course, is an essential connecting device that's capable of sending and receiving data with radio signals as well. And those access points still use Ethernet cables, right? They're connected to the internet, for instance, by Ethernet cables, copper cabling still. Okay. So let's talk a little bit more about wireless network adapters. They enable connectivity between any device and a wireless access point, and they work simply by translating bits into radio signals. And if you actually just take a look at my hands here, all that happens is that radio signals they modulate, so they sort of go up and down, and that's how they represent zeros and ones. A little different from the way that you represent zeros and ones in binary data with electricity or with light. So anyway, back to the screen. Wireless network adapters, they take a lot of different forms. Most laptops now have internal adapter cards, but there are still, and onboard wireless adapters too, which means that it just goes on your motherboard or your MOBO, as tech geeks might call it. But there are still external adapter cards and also USB adapters that allow you to connect wirelessly. Wireless access points, they can come in many forms as well. Oftentimes they're located in our home routers, our SOHO routers at our home office or small office. And, wireless access points, like I had mentioned previously, I hate to hammer this down, but they're connected to switches. Right, and we do have dedicated ones that are specifically for the purpose of sending and receiving data in large organizations. They might be hiding in a ceiling somewhere above you right now, depending on where you're watching this video. But wireless access points, they simply do that same thing. They translate bits into radio signals, and then they send or receive it. And they do a good job of receiving them and then translating them into the electrical signals that are required to transmit data to a switch or to a router. Another technology that we haven't talked about is a wireless repeater. Wireless networks are limited in how far a wireless signal can transmit. So if you think about the range of your wireless access point, it only goes so far. You could actually place a wireless repeater here at the end of a network in order to extend the signal range of a wireless access point. Repeaters do this by reading the signal coming from the wireless access point, and then they go ahead and they repeat it and send it out. And of course, we got to make sure our data finds the device there, right? And similarly, it just reverses that process in order to make sure that your device, if connecting to a repeater, is able to send data back onto the local area network and onto the internet, hopefully, right? We'll detail a little bit more about what the internet actually is a little bit later too. Next, bridges. Bridges function a very similar way to repeaters. Bridges sit in between two different wireless local area networks though. And what they do, just like bridges in real life that connect two different sides of a ridge or maybe a gully or something along those lines, is they bridge those two networks together and connect them together. This is known as bridge mode. Okay, it's I sort of find it funny every time that I use these semantic words, because sometimes there's just not a better way to describe it than saying like, oh, it bridges things. And as a teacher, I feel like I should get on my own case about using a word to define itself, but this is definitely what it does in this instance. All right, so let's talk about wireless standards. For wireless networks to function, all of the devices, all of the wireless adapters have to use the same wireless networking standards. There are a number of different networking standards that define wireless communications. They're commonly referenced as Wi-Fi, right? Those are the standards, the body of standards that dictate the data transfer rate, connection frequency, and more of wireless communications. The standard, however, is commonly referred to as 802.11, all right? So let's take a look at this chart over here on the right. This is something that's almost, I've taken this exam a couple different times and I've seen content from this particular chart multiple times. It's really important. A little odd fact, just so you know, is 802.11b was the first wireless standard created. It was the first to market, rather. Shortly after followed A. And what I want you guys to notice is that these two are the key to really understanding this whole table. B came first, so its data rate was what I say slow, and its frequency was low. Okay. A came along, and it was fast, and its frequency was high. I sort of think about the way that alleles in biology work, and I think about the fact that when you create a new technology, it sort of inherits different features from previous technologies. And so I like to think of G as sort of being a child of A and B. And so if we go back to the screen here, you'll see I always think of G as inheriting 54 megabytes per second, or not megabytes, megabits per second from A, whereas it inherits 2.4 from B. So while B is slow and low, A is fast and high, and so G is fast and low. And so if A and B were parents, right, they would pass along those traits to G. And of course, that same type of analogy doesn't necessarily work that well with N down here, but N just gets way faster with 600 megabits per second. And then of course, it uses both frequencies. It uses 5 gigahertz or 2.4 gigahertz as a frequency. So I don't know, hopefully that little analogy helped you remember the difference between those standards. Definitely something that you're gonna see on an exam. Okay. All right, 802.11n. This is the standard that's commonly used right now. There's actually one that's newer than that. I believe it's 802.11ac. But it's a standard because it's fast, right? And there are also a couple of other factors too. It supports multiple antennas. So if you have a wireless router at home, simultaneous connections and data streams can flow into that wireless router. There's also something called frame aggregation that it supports, which is just sending 2 or more frames in one transmission, so the same radio signals, which can double your bit rate. There's also something called channel bonding. So channels we're not going to detail here. It's a little bit beyond the scope of this course, if I recall correctly, or rather beyond the scope of the exam. But you don't want your channels sitting right next to each other because that can cause some problems when you transfer data. But if you're using 2 channels in combination with each other, then you're able to send twice as much data as possible, and it's really quite a positive thing for wireless communication. All right, so let's talk about wireless network topologies. So similar to wired networks, there are different ways to connect devices in wireless LANs. Recall that these arrangements are called physical topologies, but know that when you're connecting wirelessly, the physical location of your devices don't necessarily always matter as much as they do when you're using physical cables, right? So there are 2 common ways, though, to connect devices wirelessly. There's ad hoc mode and also infrastructure mode. Ad hoc mode is used by, or rather, I should say that devices are organized in something similar to a mesh topology. So if you recall from when we were talking about the mesh topology, notice that every single device is connected to every other device in the topology, right? And of course, those red lightning bolts, they resemble wireless communication. Clients they communicate directly with each other. And so this is an example of a peer-to-peer network like we had talked about previously. Ad hoc mode is used less commonly than our next mode that we're going to feature, which is infrastructure mode. And this is probably the one that you're using right now, even in your house. Could also use it at work or even at school. Okay. Infrastructure mode, most common way to connect wirelessly. What happens is like we've been talking about this entire time. Your device is going to connect to a wireless access point, which then is connected to a cable that trails off to a switch and off into a router. When clients want to connect, they use a service set identifier. So if you are connecting to the internet through an internet service provider and you have a home router, you probably are connecting by using a service set identifier, an SSID, right now. Mine at home, if I can divulge this and I'll write it up on the screen for you, is Go Seahawks. And I'm able to locate my network because of that name, right? Before a device can access the network, clearly you have to try to connect using that name, but you also are going to authenticate with a password. That password is gonna basically prove to that wireless access point that you belong on the network. Oh, look at that. I already covered all this information. Make sure to read this really quickly, and we'll go ahead and move on. One thing I'll point out from this slide is that for security purposes, you can hide the SSID from people, right? They don't have to see it. Pretty cool. So one of the things that's not often talked about with wireless communication, at least in general conversations, is that though it's convenient, it's not always secure. And that's because the data is just traveling wirelessly through the air, right? The radio signals just travel unbeknownst to us. And that means that anybody can try to access that data, right? Like it's publicly actually available out there if you have the proper technologies. And so we have to protect our wireless communications. And we do that using wireless encryption protocols. The table to the right is going to detail a couple of different wireless encryption protocols for you. You may be familiar, you may be using some of these at home. But what happens with encryption is that we scramble data to make it unreadable to hackers. We do this using keys. And the size of your encryption key is going to dictate how strongly your encryption, or how strong your encryption is, right? So the longer the key, the harder it is for somebody to hack your data. So if you have a 256-bit key, it takes a lot longer for a computer to be able to try to hack your data and figure out what kind of messages you're sending back and forth. In contrast, a 64-bit key probably isn't going to be super secure now. All right. Lastly here, we're going to talk about 802.1x. It's a standard that's used to secure wireless communications. Just three basic components within this type of a setup, all right? And you'll be able to see all these components over here on the right-hand side in this graphic. First, you got a client computer called a supplicant. Then you have a wireless access point, which is called a network access server. And then you have a radius server, which is going to be responsible for authentication. What happens in 802.1x is that the supplicant is going to contact the wireless access point, and it requests access to the network. The wireless access point then contacts the radius server, right over here on your right, to see if the supplicant's username and password is in the database. If it is, and let's go ahead and switch to green so we can say that it is, then what happens is the computer now has access. It has the green light to utilize the network and its resources. And that very well mean that all of a sudden it can start sending data out onto the internet and receiving data from web servers across the internet. All right, so that's all we've got for this module. Hope you join us next time. We'll do a quick recap here. We just talked about wireless devices, wireless standards, and also how to secure wireless networks and the technologies that are involved there. So I hope you had as much fun as I did. Thanks again for your time, and I'll see you next module.